let's find f prime of x for the function f of x equals square root of x. That's our first job. After that, we want to find the slope of the graph at the points 1, 1, and 4, 2. And we also want to discuss the behavior of the function at the point 0, 0. So our first order of business is to find the derivative of f of x equals square root of x. So there's our function, and we want to find the derivative. So f prime of x is equal to the limit as h approaches 0 of f of x plus delta x. So the square, oops, sorry, we're going to use h's, right?
Yeah.
Okay, x plus h minus f of x all over h. So, if I substitute 0 in now, I'll get 0 over 0. So that's no good. So I'm going to have to figure out a way to cancel from top and bottom an h over h, right? Okay. The way to do that is when we have square roots, try the conjugate. So what would the conjugate of the numerator be?
Square root of x plus h plus.
Right. All right. And the trick to this is to distribute the pair that are conjugates, but leave the other pair undistributed. All right, so if we distribute out the top, we get x plus h. And the outer and inner terms cancel to 0, right? Because that's what happens with conjugates.
Yes.
And then we have a minus square root of x times a positive square root of x, which is just minus x. All over h onto the square root of x plus h plus the square root of x. So the x's cancel to 0, they add out, and that just leaves me with a monomial on top and h and my conjugate on the bottom. Now we can simplify that, and we find that the difference quotient is 1 over the square root of x plus h plus the square root of x, and if we apply the limit as h approaches 0 to that, that will tell us our derivative. So if I put 0 in, what do I get?
1 over.
I get 1 over square root of x plus square root of x, which is indeed 1 over 2 square roots of x. Remember that square roots add like variables. Y plus y would be 2y, x plus x would be 2x. Square root of x plus square root of x would be 2 square roots of x. That's our derivative. That's the first part. Make sense? Any questions so far? Okay, now what we want to do is find the slope of the graph at the points 1, 1, and 4, 2. So now that I have my derivative, I can convert it to slope by simply substituting in the number that I want to find the slope at. So I want to find the slope at the point 1, 1, so I'll substitute 1 into the derivative, and that will give me what?
1/2.
So the slope is positive 1/2 at the point 1, 1. Does everybody understand what we just did there? To find the slope at 1, 1, I simply took the derivative and I plugged the point into the derivative. The derivative only has an x, so we're not using the y value of the point to do anything, just the x value. Now to find the slope at the point 4, 2, I'll take my derivative, 1 over 2 square roots of x, and I will substitute the x value of 4 here. And that gives me a slope of positive 1 over 4 at the point 4, 2. So let's look at the graph. If we graph the square root of x, most of you should remember that it looks like this, right? Starts at 0, 0, goes through the point 1, 1, it goes through the point 2, 3, 4, 2. Something like that. Make sense? Okay, so if we imagine the line that is tangent, and remember that tangent lines have nothing to do with trig, they're a geometric concept, just means the line that barely brushes the point and only touches the graph at that single point. If we take this tangent line, do you see how it is positive? And I got a positive 1/2 there. If we take this tangent line, well, not a very good tangent line, and I imagine it again, it's also positive, but just not as steep. Do you guys see that? Yeah. It's a little steeper here, than here, and a slope of 1/2 is supposed to be steeper than a slope of 1/4. And then our final question is, what's going on with the slope at the point 0, 0? What do we get there? If we get 1/0, what do we get? Undefined. The slope at the point 0, 0 is undefined. Here's why. Here's my point right here that I'm questioning. Well, a tangent line to that point is not unique. Maybe it's here, maybe it's here, maybe it's here, maybe it's here. And so if the derivative isn't unique there, it's going to show up, or if it's at a weird discontinuity, a lot of times it's going to show up as undefined, your slope is. Because in order to do that, you have to be able to have a derivative, you have to be able to get a tangent line, and it has to be unique. Any questions?